So now I am explaining you all the summary, whatever we have done earlier in the chapter, summarizing everything in this session. We will divide into two parts. In one part, we will deal with the parabola, all basic concepts, basic summary, basic formula, basic ideas. And in the second part, I will deal with the normals and all geometrical aspects of the parabola. Just summary of that. Derivations we have already done. So for parabola, first of all, if you remembered a second degree equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus 2c is equal to 0, second degree equation, can represent all conic section plus straight line plus circle, etc. everything. So when does it represents a parabola? First condition was discriminant d must not be equal to 0. Discriminant d means abc plus 2fgh minus f square minus bg square minus ch square, that you can see for the notes. D must not be equal to 0. This is represented in this way also. A, B, C, F, G, H, F, G, H. This is discriminant must not be equal to 0. If you simplify, you will get same thing. And H square must be equal to AB. H square must be equal to AB. Then the second degree equation represents parabola. For parabola, we already know eccentricity E, SP upon PM, E is equal to 1. Second thing. Focal distance of a point. Focal distance of a point is given by a plus x1 for parabola y square is equal to 4ax and a plus y1 for parabola x square is equal to 4ay. This is for y square is equal to 4ax and for parabola x square is equal to 4ay. This focal distance formula is a plus y1. Third point is focal chord. If a chord passes through focus, ends are 81 square comma 281, 82 square comma 282, then the condition is T1, T2 must be equal to minus 1. Then it is a focal chord. Second concept is length of focal chord. Length of focal chord is given by A t plus 1 upon t whole square. Length of focal chord. Third, we can find a relation between focal radii and semi-latus rectum. Focal radii and semi-latus rectum. I am explaining here what is this focal radii and relationship. Suppose this is my parabola. This is a chord passing through focus S A comma 0. This is P. This is Q. This length is called L1. This length is called L2. SQ. SP is L1. This is one of the focal radii and SQ is L2 is another focal radii. This is directrix. So here the second property is semi-latus rectum is harmonic mean of focal radii. That I can say in this way also, 1 upon A is equal to 1 upon L1 plus 1 upon L2, or I can remember in another form, that is 2A, semi-latus rectum is harmonic mean 2L1 L2 upon L1 plus L2. If I take LCM, I will get this relationship, 2 will cancel. So semi-latus rectum is a harmonic mean of focal radii. Now there are some very important properties related to tangents. A lot of question comes directly, indirectly with use of these properties in the exams based on tangents. If at P, if I draw a tangent, if this point is at1 square, 2at1, then equation of tangent is given by ty is equal to x plus at square. This is the tangent at at square, 2at. This is a tangent at a point T. Slope form of tangent is also there. Slope form, if slope is given, slope form of tangent y is equal to mx plus a upon m is the tangent. Remember, this is the tangent for our standard curve. Standard curve means y square is equal to 4ax. Y is equal to mx plus a upon m is the tangent in slope form, where m is the slope of the tangent. Now suppose I draw tangents at 2 points P and Q. At 2 points I am dropping tangents at P and Q. Then this point of intersection R is a T1 T2 comma a T1 plus T2. This is nothing but geometric mean of their x coordinates, and this is a arithmetic mean of their y coordinates. Now you can imagine here, if PQ is a focal chord, PQ is a focal chord, then T1 T2 will be minus 1. So this x coordinate will be minus a. That means tangents drawn at ends of focal chord will always, two things will happen here, will always intersect on directrix intersect on directrix. And second point is the tangents drawn at ends of focal chord will always intersect on directrix. And as they are intersecting on directrix, as we know, directrix is the equation of diagonal circle, so they will be always mutually perpendicular, will always be perpendicular to each other. Or in other words, I can say that from any point on directrix, if I draw a chord of contact, that chord of contact will be always focal chord. So this point can be represented in this way. The chord of contact with respect to any point on directrix will be focal chord. That means this chord of contact, any point you can choose here, anywhere. With respect to that, if you draw the tangents and if you join their points of contact, then that chord of contact will be always a focal chord. So these are very important properties related to, basic properties related to tangent and general points.